Hello everyone, welcome to week 5 part 3, Introduction to Algorithms. These standard library algorithms are function templates that perform such common data manipulations such as searching, sorting, and comparing elements or entire containers. This standard library provides many algorithms. Most of them use iterators to access container elements. And each of those algorithms has a minimum requirements for the type of iterators that can be used with it. Common containers support specific iterators types, some more powerful than others. A container's supported iterator type determines whether the container can be used with a specific algorithm. Iterators encapsulate the mechanisms used to access container elements. This encapsulation enables many of the algorithms to be applied to various containers independently of the underlying container implementation. This also enables you to create new algorithms that can be processed or that can process the elements of multiple container types. The standard library provides scores of algorithms you'll use frequently to manipulate a variety of containers. You have inserting, deleting, searching, sorting, and others are appropriate for some or all of these sequence and associative containers. The algorithms operate on container elements only indirectly through iterators. Many algorithms operate on sequences of elements defined by iterators pointing to the first element of the sequence and to one element past the last element. Sequence containers. The C++ Standard Template Library, or STL, provides 5 sequence containers: array, vector, dequeue, list, and forward list. Class templates array, vector, and dequeue are based on built-in arrays. Class template list and forward list implement linked list data structures, which we'll discuss later. Performance in choosing the appropriate container beyond these operations, each container typically provides a variety of other capabilities. Many of these are common to several containers, but they are not always equally efficient for each container. In the example that we're going to see later on slide 4, we are going to present the operations common to most of the standard library containers. Standard library algorithms. Some of the STL or the standard library algorithms are fill, fill in, generate, and generate in. Algorithms fill and fill in set every element in a range of container elements to a specific value. On the other hand, algorithms generate and generate in use a generator function to create values of every element in a range of container elements. The generator function takes no arguments and returns a value that can be placed in an element of the container. Let's take this example. This programming example demonstrates the algorithms fill, fill in, generate, and generate in. In this slide 4, let's look at the algorithms fill algorithm and fill in algorithm. So the fill algorithm, starting with from line 13, it defines a 10 element array of char values. Line 15, it uses the fill algorithm to place the character 5 in every element of chars from chars.begin up to but not including chars.end. These iterators supplied as the first and second argument must be at least forward iterators. What that means is they can be used for both input from a container and output to a container in the forward direction. So looking at the fill-in algorithm starting with line 21, you can see that the fill-in algorithm used here to place the character A in the first 5 elements of vector chars. The iterator supplied as the first argument must be at least an output iterator. See the difference here with the fill-in, it's a forward iterators, but with the fill algorithm, it's a forward iterators. With the fill-in algorithm, it's an output iterators. And on output iterators, it can be used to write into a container in the forward direction. In the fill algorithm or the forward iterators, it can be used for both input from a container and output to a container in the forward direction. So the second argument in line 21 specifies the number of elements to fill. The third argument specifies the value to place in each element. So here we looked at the fill and fill-in algorithms. Now let's look in the part 2 of the example at the generate algorithm. Starting with line 27. Line 27 uses the generate algorithm to place the result of a call to generator function next letter in every element of vector chars from chars.begin up to but not including chars.end. The iterator supplied as the first and second argument must be at least forward iterators. Function next letter lines 42 to 46 begins with the character A maintained in a static local variable. The statement in line 45 post increments the value of letter and returns the old value of letter each time next letter is called. So the statement in line 45 post increments the value of letter and returns the old value of letter each time next letter is called. Going back up to line 33 to the generate n function or generate n algorithm, at this line the generate n is being used to place the result of a call to generator function next letter in 5 elements of vector chars starting from chars.begin. And if you notice that the iterator supplied as the first argument must be at least an output iterator. So here we looked at the generator or the generate algorithm, and the previous slide we looked at the fill and fill-in algorithms. And these are the output of the program